Hey guys, we're going to do badge 10. So I'm just calling badge 10 a chi-squared test for a two-way because when you look at the calculator, there is no difference. So we kind of, in our notes, we can see them read through. I'm just going to take my highlighter and walk through. What is a chi-squared test for homogeneity? Well, we essentially decide, and we set in our notes, it's when you have multiple samples and one variable. All right, so what does that mean? It looks like in this example, we said a recent study tracked television view habits of 100 boys and 100 girls. Each child was asked their favorite show. Okay, so it looks like two variables here, but essentially we're thinking about this is a sample and this is another sample. So notice we asked one question, what is your preferred show? And they had three options, and this is a different sample. And so we're essentially deciding if the two samples are homogeneous, which is why this is a test for homogeneity. So what are we trying to find? We're trying to find whether or not there's convincing evidence that the TV preference differs between boys and girls. So what must we assume? We must assume it doesn't differ, that regardless of whatever the show is, the girls and boys like it the same amount. So what would the data look like if it was absolutely the same across the board? If it was the same across the board, we said that if we did a side-by-side plot with boys and girls, and this would be 100%, that essentially whatever the breakdown, so if this was 20, 30, and 50, then this one should also look 20, 30, and 50, or something pretty close to it. So we already kind of see that it doesn't look the same. As we see here, the girls are 70. Oh, these aren't percent. Okay, so that's I'm like, hold on a minute. Let me think about this. So this is 20, 30, 50. That is 100 total. But it looks like we asked more girls. Okay, so that's not a percent. So in order to do a side-by-side, I have to, that would be 35%. It just so happens that's 20%, right? That's 30% because 30 of 100. And that's 40%, and that's 25%. So a total of 200 girls were surveyed. 35% said the first group. 40% said the second group, and the smallest amount, 25%, said the last group. So we notice that these don't look the same. So we already can in our gut know that it looks like we do have convincing evidence that the preference of shows do differ between boys and girls. But let's track down each of our components. So generally, regardless of what they ask of us, we can say that the null hypothesis is there is no difference in the distribution for the several samples. And so alternatively, we want to say there is a difference in the distribution between the several samples. Here we have two. Plan, it looks like we have the same exact thing. When we're sampling without replacement, check for the 10, expected counts at least 5, and we want to make sure that the samples are random and independent from one another. Do, the do is exactly the same, although our calculator will find our degree of freedom. So here's our formula for the degree of freedom. Number of rows minus 1, number of columns minus 1 is our degree of freedom. Now our calculator will calculate this for us. So we have 2 rows and 3 columns. So our degree of freedom on the calculator, which will do that for us, will be 2, but we'll know how it got there. All right, now conclude. We know this is the same as we've seen before. Okay, so let's go ahead and do it. So there is no difference in the distribution. There is no difference in the distribution of shows between the two populations. All right, and so alternatively, we're trying to say, I think that there is a difference. In the distribution. Now, I'm not essentially saying what it is, so we want to be very careful. I'm not saying that it is this or it is that. This is merely a sample. All we're saying is that whatever B is, the boys, and whatever G is, the girls' distribution, their distributions are different from one another. Okay. So, plan, excuse me. Samples were taken randomly. Expected counts. It looks like we asked a lot of people, so I'm thinking our expected counts are going to be greater than 5. We'll come back and address that. We're going to have independence because our population of boy cartoon watchers. So that's our population. And girl population watchers. Is greater than 1,000 for boys and greater than 2,000 for girls. Okay. Our chi-squared value. We're going to let the calculator do most of this work. And then our calculator will give us a value. It will give us a degree of freedom, row 1, column -1, multiply that. Our calculator is going to give us a p-value. Then we're going to use that p-value to make a conclusion. Okay. Here comes the hard part. I'm going to try to do this while holding my iPad at the same time. Okay, so here we go. Let me stick my calculator underneath there. Turn it on, calculate. And we want to call it something. So I'm going to call it Perry for Perry the Platypus. That was one of the shows, Phineas Perry. What were the observations made by these kids in their cartoons? So I'm going to hit the button. I named it, my observations, control boxes, and then boxes again. And I'm going to select that button. All right, we had 2 rows and 3 columns. So I use my tab to navigate. Okay, so now I need these values. Now I have this printed out. Let's see, hold on. I had this printed out, let's see. I don't want to go back to my online one. Okay. Beautiful. There it is. There are those values. So we want to put these in our calculator. Okay, 20, 70, 30, 80, 50, 50, enter. Those were the observations of the cartoon watchers, right? Now for the dirty work. The calculator will do all of it for us, and we're going to go down to chi-squared two-way test. All right, our observed matrix is Perry observations, and we hit OK. And this is the information we need. Ooh, wow. So we do know that there is a preferential difference between girls and boys, and we kind of saw that in our side-by-side box. We want to see where exactly, so we're going to hit our variable button and hit expect and enter. And then we'll hit our variable button again, and let's see the composition. Where were each of those numbers added together? Okay, so to get our chi-squared value, they added up these numbers, and they got that. Okay, so let's go back to our work here. I think we've got all the numbers we need to be dangerous back on our sheet. So let's switch back to our notes here. All right, our chi-squared value was 19.3, and our p-value was really small. All right, so we now know we're going to have a follow-up. We're going to have to say, wow, somebody was watching this show way more than expected, or nobody was watching this other show in the girls, okay? Or the boys, whatever we're going to conclude here. We're going to find out where we get this. But first, let's finish off our conclusion. Because our p-value of 0.00064 is less than 0.05, we reject the null hypothesis. We do have sufficient evidence to support H sub A. Now, what is H sub A? To support that there is a difference. So is that what we set out to prove? Yes. We wanted to prove that there was a preference, or that there is a difference in preference between the boys and the girls. And that's exactly what we've done. So to support that there is a difference in preference, TV show preference, between boys and girls. Okay, now let's get into the calculations, because I think that's what's going to really show us what did we observe? Well, we observed 20, but our expected said 30, okay? We observed 30, but we expected 36.6 repeating. All right, dot, dot, dot. Our last one, so these, there should be 6 of these added up. The last one, we observed 50. We expected 66.6 repeating. Squared over expected. And all this added up to that 19.3. So what were each of these numbers? Well, there were 6 numbers. The first one, this one, was 3.3. The next one, this one, was 1.2. The next one was 8.3. The next one, 1.6. The next one, 0.6. And the last one, 4.2. Those add up to 19.3. All right, so we see here, where was this comprised? It looks like the biggest difference was here. We could also talk about here, but definitely we need to talk about here. So what was that on? So it's like 1, 2, 3. This one was the biggest shock. So I'm actually going to put the numbers right next to here. They expected 30. They expected 60. Neither of these are that far off, right? They expected 36 or 37 if we round up. They expected 73. So nothing's too crazy. But here they expected 33. Here they expected 66. So the number that had the highest was this one, and the number that had the highest was that one. So essentially it's showing that we expected 33, but 50 watched. It's not quite double, but it's quite a bit more. We expected 66, but only 50 watched. All right, so I think we're ready for a conclusion here. More boys watched Phineas and Ferb than expected. We expected 66 women to watch Phineas and Ferb. So we could also say fewer girls watched Phineas and Ferb than expected. All right. How do I tell the difference? Well, again, these were our observations, and our expected is calculated here, right here. How do we calculate the expected counts? Our calculator does this for us. So we notice in our table, there was a total of 100 guys, right? And 50 watched Phineas and Ferb. And 50 of the girls watched Phineas and Ferb. And so that means there was a total of 100. So that's why we were getting, what do we expect for this box? Row total, 100. Column total, 100. Divided by grand total, 300. So a third of 100 is 33. So what is the expected value? That would be the expected. How did they calculate this one? The expected would be row, 200, column, 100, divide by grand total. So that's 2/3 of 100, or 66. So this is how the calculator calculated those expected values. Nice work, guys. See you next time.